Hello, grade 10s. Okay, this is a continuation of lesson 5.3, but now we're going to focus solely on graphing. So once you understand the vertex form of a quadratic relation and you understand the role that each of these values play, you can produce the graph accurately, okay? So I think what I'm going to do is put this on hold for a sec, and we are going to start by graphing y equals x squared, okay? That is a very simple parabola, nothing special. We didn't reflect it, we didn't stretch it, it wasn't compressed, we didn't translate it horizontally or translate it vertically. Okay, so this is what every single parabola starts out as, all right? Okay, so let's create this table of values. If I square -2, I get +4. Remember, we're not just squaring 2, we're squaring -2. So you square the sign and the number. When I square -1, I get 1. When I square 0, I get 0. When I square 1, I get 1. And when I square 2, I get 4. Okay, these are my usual suspects from grade 9, right? Generally in grade 9, when you went to graph, these were the x values you used in your table of values. Now we have graduated to a quadratic relation, and so the y column is calculated differently. All we're doing is squaring the x value. Okay, so I already got this guy ready to go, and all I'm going to do is plot these 5 ordered pairs, okay? And I'll do it in blue so it's color-coded. So we've got -2, +4. We've got -1, 1, 0, 0, 1, 1, 2, 4. Okay. So that is how you accurately graph y equals x squared. Okay. As I'm sure you've probably learned navigating Unit 5, we're going to graph quadratic relations that are a lot more complicated than y equals x squared, so we need a really good strategy that doesn't involve Desmos, because if you plan to take grade 11 functions, you will be graphing till your eyeballs fall out. So we're going to come back over here for a second, okay? So this tells us whether or not there's been a reflection in the x-axis, and it also tells us if the quadratic relation has been vertically stretched or vertically compressed. The day that I produced my video for 5.1, I talked about the fact that the value of a only affects the y values, okay? So if we come over here, these guys are not going to change. I'm still going to use these as my x values if I were to produce a table of values, but my y values will be altered, okay? So let me show you what that looks like with a specific example, okay? The specific example I'm going to use is okay? Hopefully by this point, you've done enough homework and enough practice that if I give this to you, you can describe the transformations to me with no issues. Reflection in the x-axis, vertical stretch by a factor of 2, horizontal translation 1 unit to the left, vertical translation 3 units up. Okay, so that's great, and that's a very important skill, but we also need to be able to graph this accurately, and that's what we're about to do using a transformation table. Once you kind of master this skill, it makes graphing so much easier. So as I said earlier, okay, this guy only affects my y values. So what I'm actually going to do is add on to my table of values. I'm going to add another column, and this is going to be my A column. And this is where I'm going to show what kind of impact the A value has on this quadratic relation. So because my A value is -2, I'm going to multiply all of my y values by -2. These guys do not change. The A value doesn't impact the x values of your table of values. So all I did was take my A value and I added an extra column to my table of values, okay? Now, this guy tells me that I have shifted the parabola 1 unit to the left, horizontal translation 1 unit to the left. When we move the parabola from side to side, we are not impacting the y values. So now Ooh, look at how nice and straight that line is. Now I'm going to add an additional column to my table of values to show that there is a horizontal translation 1 unit to the left. So I'm going to move all of these x values 1 unit to the left. Instead of -2, this would be -3, -2, -1, 0, 1. I subtracted 1 from each of these x values, okay? There's one thing we haven't addressed yet, and that's the fact that this guy was vertically translated 3 units up. And I need a color for that. Hold on. Okay. So when we translate a parabola, okay, vertically up and down, we're not impacting its x coordinates. We're only impacting, oh my God, that's so bad. It's y coordinates. So this is a vertical translation 3 units up. So I'm going to take these existing y values and shift them up 3 units. So if I add 3 to this, I get -5, 1, 3, 1, -5. Okay? Why am I doing this? Because now I have a table of values that I can use to accurately graph this, okay? And when I do that, folks, I needed to work through this process, but now these 3 columns in the middle are not really necessary. I'm going to be looking here and here, okay? These are 5 ordered pairs. This is the ordered pair -3, -5, -2, 1, -1, 3, 0, 1, 1, -5. Okay, so let's go back to our original graph and actually plot those points. All right, so -3, -5, -2, 1, -1, 3, -1, 3, 0, 1, 1, -5. Okay, I really hope this is not going through on my granite countertop. Okay. So, and this is the graph, y equals -2 x plus 1 squared plus 3. So in using the transformation table, I was able to see how each transformation impacted the ordered pairs of the quadratic relation. So when you go to graph these guys, you're always going to have these guys as your starting column. And then if there was a horizontal translation, you're going to have an additional column over here that only impacts the x values. And if there was a vertical stretch or a vertical compression or a reflection, you're going to have this extra column here. And then if there was a vertical translation, you'll have this guy here. Okay, so a plane parabola has a 2-column table of values, and then the additional columns depends on the transformations. Okay, and then again, why are we doing this? Because it allowed us to produce 5 new ordered pairs, which were used, and I know this looks terrible, just pardon me, it's like 1 o'clock in the morning, which allowed me to graph this quadratic relation accurately. Okay? Okay, let's do another example just for fun. So before I even think about graphing this, I'm going to create my table of values, -2, -1, 0, 1, 2. Okay, my usual suspects, you've been using these guys since grade 9. And then of course, for the graph of y equals x squared, I square these guys. Okay, now, this has been vertically compressed by a factor of 1/4. Okay, there was no reflection, just a vertical compression. So I need to show what that is going to do to the y values. This does not impact my x values. So what I'm going to do is multiply each one of these by 1/4. 1/4 of 4 is 1. 1/4 of 1 is 1/4. 1/4 of 0 is 0. 1/4 of 1 is 1/4. 1/4 of 4 is 4. Okie dokie. Now, Where's my pink? There we go. This guy has been horizontally translated 3 units to the left. Horizontal translations, think about it, right? Going left and right. The y-axis certainly doesn't move to the left and to the right. It's the x-axis. This only impacts the x values. So horizontal translation 3 to the, if I said right, I'm wrong. I'm sorry. It's to the left. I apologize. When you're in the brackets, you're being lied to. So what I'm going to do is subtract 3 from these x values I started with. -5, -4, -3. Oh my God, it's late. -2, subtract 3, -1. Okay? This particular quadratic relation did not undergo a vertical translation. There is no k value. We didn't move it up or down. We're done. Okay? This transformation affected my y values. This transformation is the only one that can affect my x values. So now it's almost like I want to pretend these guys aren't even here, and these are my 5 ordered pairs that I'm going to use to produce my graph. Okay, so hold on. Okay, I think I'm going to use that same grid I used a minute ago. So my ordered pairs are -5, 1. Okay, and is this easy to graph? No, it's actually kind of a pain, but you need to do it, so suck it up, buttercup. -4, a quarter. -4, a quarter, like right there. -3, 0. -2, a quarter. So hard to graph. -1, 1. -1, 1. Okay. All right. So this here is the graph of y equals a quarter x plus 3 squared. Okay. And it kind of makes sense. This reconciles with what we've been talking about. Vertical compression. Notice it's the widest graph of all the ones that I've plotted. Okay, we moved it 3 to the left. Yeah, totally. The vertex is sitting 3 units left or to the left away from the origin. And it's sitting on the x-axis because we didn't move it up or down. Okay, so I hope this helps. By all means, message me with questions, and I think I will post some supplementary worksheets to help with this.